Hey everybody, time for another video. This time I'm doing the homework from 8.5. It says basic factoring and factoring by grouping up here. Um, this is related to, again, section 8.5 in our book, where we're going to be factoring out a greatest common factor, and on some later problems we're going to be factoring by grouping. So follow along if you want while I go through a few of these here, and yeah, let's do it. So in problem number 1 here, it says factor, and it says 6c cubed plus 8c squared. Now when you're doing this, what you're trying to do is figure out what's the biggest amount I can divide out of each one. So I start with the numbers. I say if you compare the numbers in front of each term, known as the coefficient, what's the most I can divide those by that they both will divide by? So in my case, this is, draw a little arrow over here, this is set 2, right? I can't divide anything else out of 6 and 8 besides 2, so I put a 2 out front. Okay, then we look at like variables. So in this case, c to the 3 and c to the second. Now you'll say to yourself, oh, they both have a c, so I'm going to write a c outside, which is true. But don't always assume it's just a letter. You can always take whatever the lesser exponent is. So in this case, c squared is the least thing I see, so it actually is the amount that's divisible out of each of those. So 6 and 8 formed together to pull out a 2, because that's what you could remove. And c to the 3 and c to the 2 form together to pull out c to the second, because that is the least amount of c's I could take out of anything, or the most I could take out, because only one of them has that much to give. Okay, then I write what's remaining in there. Oops, okay. Boop. So anyways, the remainder is 3c plus 4. And if you're wondering where 3c plus 4 came from, 6 divided by 2, the thing I took out, leaves us with 3. C to the third divided by c squared leaves me with c. And on the second guy, 8 divided by 2 is 4, and c squared divided by c squared essentially cancels out. If you're wondering why I'm reducing those things inside the parenthesis, like the way they are, that's because if you think about it, c to the third divided by c squared, this is learned in a previous chapter, you subtract and get c to the 1. So that's why 3c is left over. And on the other one, c squared over c squared makes c to the 0, which equals 1. And instead of writing 4 times 1, it's just better to write 4. Whew. Okay, that was a lot of explaining. I hope it makes sense. So 2c squared 3c plus 4, parenthesis. Okay, we'll do another one in a second, hopefully. That will be helpful. Oh, whoopsies, gotta make that white, so when I delete, it makes it all like that. Okay, next problem. 25w plus 20w squared. So I say, okay, out of these two things, what can I take out? I can take out a 5, they're both divisible by 5, and a w. This time I can't take out more than just w because this first term here only has a single w to give. 5 plus 4w is what's left over when I divide by 5 on the 25 and 20. And w squared only goes down to w. And that's it. Now here's the deal. You should always be on the lookout for problems like this. In the future of like the factoring we do, there's sometimes opportunities to divide something out first, and you should always try and do it if you can. Sorry, I had to sneeze. On these next problems, it's still got 2 terms for us, but the terms are increasing in difficulty because they have multiple letters now. So let me write this guy down. 18, v to the 7, x to the 5th, 12v, x squared, y fourth. Okay, so based on the numbers, 18 and 12 are divisible by 6. Now v to the 7 is in the first guy, but there's nothing in the second one, so I actually can't divide out anything with a v. So I'm going to leave that where it is. X to the 5th, and wait a second. I lied. I thought it was not a V, but it's a I thought that was a U. Never mind. There is a V to the 7th on this one and V to the 1 on that one. Okay, my mistake. So I can't take out a V. That's a lie. So in this case, I can take out V. I have to take out the lesser choice. This guy has 7 to give. The second only has 1 to give, so that's the best I can do. All right, on to the x's. Oh, geez. X squared is what I can take out. I can take out 5 here, but only 2 here, so I have to take out what I can. Okay, now in the second term, y to the 4th cannot be removed because there's no y term in the first. It's not something I can factor out, you know? So I'm going to leave that one alone. Okay, after I divide by 6, I get 3. If I take out v from v to the 7, I'm left with v to the 6. If I take out x squared from x to the 5th, I get x to the 3. On my second term, I get 2, 12 divided by 6. The x and the v are gone. These two canceled out based on what I took out. Now, it's not always going to be the case that it cancels out completely with one term. Like maybe the x is completely removed from one term and the v is completely removed from one other term. But it is very possible that each letter will, at least in one term, go completely away. In this case, the v and the x go away, leaving 2y to the 4th. So I took 6v x squared out from each term, which left me with 3v to the 6, x to the 3rd on the first term, and 2y to the 4th on the second term. Okay, another one. 16u to the 3, w squared, x to the 4th, 12u to the 9, w to the 9. So in this one, the first guy has an x, but the second guy does not have an x. I got to keep that in mind so I don't mess up. Okay, 16 and 12 are both divisible by 4. They both have u, but the first term has u to the 3, which is the most I can take out now. The first term also has w squared compared to w to the 9, so I can only take out w squared at most. So in this case, the first term had 2 guys that removed. So when I take out 4, 16 divided by 4 is 4. The u and the w are gone, but x to the 4th remains. Second term, 12 divided by 4 is 3. U to the 6, w to the 7. Notice I'm reducing the 9s by however many I had taken out. 4u to the 3rd, w squared. There's a lot of typing exponents on this thing, that's for sure. Okay. All right, on to the next kind of problems. These are called factoring by grouping. Now you'll notice on this one, let me write it down real quick, that it's impossible to factor something out directly. For example, if I look at the numbers 5, 3, 35, and 21, you can't divide those by a common thing. On all the other problems before, by the way, we had 2 terms, but it didn't matter if it was 2 terms, 4 terms, 8 terms. You would try and see if you could divide something out. In this case, there's 4 terms. So, usually when there's more terms, it's hard to find a common factor, right? So 5, 3, 35, 21, nope, can't divide those by a similar number. And I can't take out a letter because some of these have x, but this guy down here doesn't even have an x, so it's impossible to remove x from everything. So is it possible to factor? Potentially. So we do this thing called factoring by grouping. So what I'm going to do is I'm going to show you the way we were learning in our class, which was to make a 2x2 grid. The reason why is we're going to take the first 2 terms and put them together in a row. And the second 2 terms, or the last 2 terms I should say, and put those together in a row. Notice I'm omitting the plus sign. If you want to write the plus signs, that's totally fine. So on the first row, what you do is this. You look at the 2 things in that row and say, what could I divide out? Like pretend you're doing one of those earlier problems. Like what could I divide out of this? Well, 5 and 3 I can't do anything with, but they both have x. And I can actually take out x squared from both of them because that's the minimum. The second row, 35 and 21, I can take out a 7 because they're divisible by 7, but there's no way I can take out an x. The first column I can divide by 5, and I can take out an x. And the second column I can divide by 3. And that's it. You can also check to make sure it works. Like, do these things I wrote on the outside multiply to create what they cross at? Does 3 times x squared make 3x squared? Does 3 times 7 make 21? Yes, yes, yes. If it's working out, then you have it right. So that means the final answer here will be x squared plus 7, 5x plus 3. Sorry, so quiet there for a second. All right, just typing stuff in. It just takes a lot of time to type. All right, we'll do another one here. So 3w to the 3, 4w squared, 21w, 28. Okay, cool. So I say, okay, I'm going to make a little 2x2 box. I'm going to write the first 2 items in there. Second 2, like this. Okay, factor stuff out. First row, I can take out w squared. Second row, I can take out 7. First column, I can take out 3 and w. And second column, I can take out a 4. So I'm just going to go ahead and write the answer over here if you don't mind. It doesn't matter if you write the thing from the row first or the thing from the side first. You should get it right either way. Perfect. All right, another one. This one is slightly different because it does have a negative sign on it. Negative signs can cause some slightly different answers here. 2w to the 3, 5w squared, 4w and 10. Boop, boop, boop. 2w to the 3 minus 5w squared. Notice I'm putting the sign on the minus guy. That's very important. Negative 4w and 10. Okay, and I take out what I can. I can take out w squared from this first row. I can take out 2 from 4 and 10. I can take out 2w here, and I can take out 5 here. Now, this is a very important step. These are not automatically the answers. You have to confirm that the outsides would multiply to make the insides. So 2w times w squared, does that make 2w to the 3? Yes. However, 2w times 2 does not make negative 4w. Something needs a negative sign. Now, by that logic, I would say to myself, okay, well, the first 2 guys made what I wanted here. So I shouldn't change the 2w, right? Like if I make that negative, it's not going to make this first thing. But if I do make the 2 negative, now the 2w and the negative 2 works out so nicely, right? Oh, but wait, we should check every box. Does 5 and w squared make negative 5w? Not if I don't make this negative. Okay, now let's confirm. Negative 5 times negative 2, does it make 10? Yes, it does. Now, so that's good. It's a little tricky. You have to kind of think about like what signs could possibly be needed. And that will occur when some of your terms are negative at the beginning of the problem. So very important that you make sure to look it over. Like there's no reason not to be 100% sure you're right. You can literally just take exactly what you just thought was the answer and multiply it back out and see if it makes the problem again. Because if it does, then you've done it right, you know? All right, here's another one. And this one has negative signs on it. So me would be saying, oh, okay, I should expect some negatives to be part of my answer. You can't make a negative in an expression without using some negatives in the middle of the problem, or the factors, I should say. Okay, so I'm writing my little 2x2 grid. 2w to the 3, 5w squared, minus 4w, minus 10. First row, I can take out w squared. Second row, I can take out a negative 2. Now, on the last one, I didn't bother taking out a negative initially, but when the row has 2 negatives in it, it's appropriate to take out a negative right away. This first column is 2w, and the second column is 5w. And then if not 5w, just 5. Sorry, 5. And if I go through and I can confirm 2w times w makes 2w to the 3, and 5 times w squared makes 5w squared, and the 2 and the negative 2 make negative 4 like I want, and everything's looking great. So That means this must be the right answer. W squared minus 2 2w plus 5. All right, the next couple of problems, the next two, have multiple letters. You can still factor it by grouping. They can get tricky, though. So let me write this guy down real quick. The order in which you write it is very important. On the previous problems, the order they were written was standard form. The highest exponents was first down to the lowest. On this one, you have to make sure you input it correctly. VU should go first because it has a V and a U, which is at least one thing in common with the following two terms. So this is written in kind of a, 3V, not 3U. This is kind of written in a fine order as it is, but that's not always going to be your case. So please make sure that if you have multiple letters, try and put the thing with the most kinds of letters up in the corner. That will allow you to factor out the most. For example, first row I can take out the letter V. Second row I can't do anything, so I'm going to say 1. First column I can take out the letter... Wait, which one of these was a U? I'm not very good at writing a V and a U, am I? Here, hold on. Oh, geez. Like this. Okay, sorry. This guy was supposed to be a U. Okay, anyways, first row, take out a V. Second row, can't take out anything, so I put 1. First column, I can take out the letter U. And second column, I can't take out anything. So, this is a dilemma, and this is why the order is important. So if I write, right now, the number 1 here, because I can't divide out anything, right? I can write. Man, who's watching this and thinking, man, is Mr. P dumb? Sorry, this was 21. Okay, I can divide stuff out. I'm so dumb. 7, U, and 3. Gosh, okay, never mind. Scratch what I was saying. I had the wrong number, but now I have the right number. So I could take out a 7 and a 3, but wait, there's still a problem. Minus signs are required on these guys because that's how I can make these two negative while keeping the 21 positive. And everything will work out there. Oh my goodness. So I get V minus 7, that was the column. U minus 3 was the row. Whoopsies. I clicked back. That's okay. Same problem. V minus 7, U plus, no, minus 3. Okay. My mouse has a side button, and if you click it, it goes backwards. Lame. All right, let's do this one, but I will try and do a little bit better than the last guy. I don't know. Just not paying enough attention. All right, so 18W, WX, 2X, 9W squared. This one's a very tough problem. I've had a lot of students in the past week say, I can't figure out how to set this up. And I understand because it has W and X, and there is a way you have to set it up. So as I was saying a minute ago, W and X has a lot in common with other things. So I'm going to write that first. So negative WX. 9W squared, squareds are pretty big deals. So if possible, I would write that next to connect it to the W of the original. And I would say the next thing to do would be to maybe put the minus 2x down here because it connects the x's. And that allows me to take the 18w I haven't used yet and line it up with the w squared. So you want as much to line up as possible. Does it have to be in this order? Actually, no. If you'd written 9w in the original corner and then like wx, like what I'm trying to do is find connections. So w connects to w, and this w connects to that w, and this x connects to this x, and this 2 and the 18 don't have a lot in common, but there's probably going to be a row, maybe 2, that don't have a lot in common. So here I can take out a w, here I can take out a 2, here I can take out a negative x, and here I can take out a 9w. Now it is very important you make sure everything works. Does w times negative x make this? Yes. 9w times w make that? Yes. Negative x and 2? Yes. Okay, it works. I will enter that over here as w plus 2 for the side. And you could write negative x plus 9w, but I'm instead going to write 9w minus x. If you reverse the order on this row over here, that will be okay. Boop, boop. All right, that does it. Factoring stuff out and factoring by grouping. You know, factoring by grouping is going to make a reappearance on 8.6 part 2. So be prepared to see that in the future if you watch this video. If you watch this video, thanks a lot. You know, you're helping yourself and actually learning something and not relying on photomath. All right, that's all I got to say about that. And I'm going to stop the recording and I'll see you on the next one. Bye.